What China found on the moon? What if everything we thought we knew about the moon was just the beginning? Imagine a world not of dust and silence, but one that was once a fiery, molten ocean of magma, stretching across even the mysterious far side we've never set foot on. China's Chang'e 6 mission has just returned with groundbreaking evidence that could rewrite the moon's origin story forever. But how did scientists uncover this hidden chapter of lunar history? And what does it mean for the future of space exploration? China's Chang'e 6 spacecraft has made a historic finding that is changing our perception of the moon. Strong evidence points to the possibility that the moon's far side was originally covered by a huge ocean of molten magma rather than water. This discovery provides an unparalleled glimpse into the moon's geological evolution and supports long-held theories on its fiery beginnings. In addition to being a scientific achievement, Chang'e 6 represents a technological and strategic turning point for China in the expanding international endeavor to study and comprehend our solar system. Chang'e 6, one of the most ambitious and intricate lunar missions to date, was launched by the China National Space Administration, CNSA, in May 2024. It was the first mission ever to collect samples from the far side of the moon, which had long been inaccessible because of communication issues and the logistical hurdles of a safe landing. The mission collected about 1,935 grams of lunar material and made a soft landing in the South Pole Aitken Basin, one of the largest and oldest known impact craters in the solar system. We anticipate that these materials will fundamentally alter our knowledge of the composition, history, and geology of the moon. For decades, scientists have been fascinated by the moon's far side, which is sometimes mistakenly called the dark side because of the striking geological difference with the near side. The far side contains fewer volcanic features and is more extensively cratered than the near side, which has vast basaltic plains, Maria. No mission had ever brought back tangible samples from this mysterious area until Chang'e 6. The Chang'e 6 mission's strong support for the lunar magma ocean theory is among its most important scientific findings. This idea states that soon after the moon formed, some 4.5 billion years ago, it was engulfed in a global ocean of molten rock. The enormous energy released during the moon's formation, possibly as a result of a massive impact event involving a planet the size of Mars and the early Earth, probably caused this molten condition. This molten ocean started to crystallize as it cooled over millions of years. Lighter materials like plagioclase floated to form the moon's crust, while heavier minerals like olivine and pyroxene sank to produce the moon's mantle. In addition to forming the moon's internal structure, this process established the groundwork for its intricate geological past. Basalt fragments with geochemical characteristics remarkably similar to those discovered on the moon's near side during earlier missions, including as China's Chang'e missions and the United States' Apollo program, are among the samples gathered by Chang'e 6. These parallels show that the moon's two hemispheres experienced identical volcanic processes, which strongly implies that the moon's early molten state was a worldwide phenomenon. The Chang'e 6 results offer the most concrete proof to date that a worldwide magma ocean occurred on the moon's far side, albeit the concept is not wholly novel. This contradicts previous beliefs that the near side was the primary location of volcanic activity and hence the evidence of a magma ocean. Important proof that the same magmatic processes that created the moon's near side also happened globally was provided by the discovery of basaltic rocks on the moon's far side. This supports the idea of a molten phase that covered the entire moon in its early history and shows a more uniform geological evolution than previously believed. Scientists have been able to determine the age of the volcanic activity on the far side thanks to the isotopic compositions of the rocks, especially those of uranium, thorium, and lead. The findings imply that magmatic activity persisted on the moon for a longer period of time than previously thought, which might add hundreds of millions of years to the lunar interior's thermal history timescale. For both strategic and scientific grounds, the Spi'e Basin was carefully chosen as Chang'e 6's landing location. The Spi'e Basin is one of the oldest and deepest impact features in the solar system, measuring around 2,500 kilometers in diameter and up to 8 kilometers in depth. It is a unique geological archive due to its sheer size. The Spi'e Basin, which was created by a massive asteroid impact about 4 billion years ago, most likely revealed material from the moon's upper mantle or lower crust, which are normally covered beneath the lunar surface. Chang'e 6's sampling of this area has given researchers access to minerals that provide direct hints about the moon's early geological activities and deep interior. Given the presence of volcanic rocks nearby, it is possible that the SPA impact caused volcanic activity by causing the crust to fracture, which brought molten rock from the mantle to the surface. This supports the notion that the moon's volcanic terrain was significantly shaped by huge impacts. In addition to the scientific advancements, Chang'e 6 is a significant technological achievement. Complex coordination between return capsules, ascending vehicles, landers, and lunar orbiters was required for the mission. The Kuekiao relay satellite, which was positioned near the Earth-Moon L2 Lagrange point to ensure a continuous line of sight, was necessary for communications between Earth and the far side of the moon. This accomplishment demonstrates China's expanding space exploration capability. China has shown that it can carry out extremely complex, autonomous sample return missions on a worldwide scale with Chang'e 6. Future initiatives, like as potential human landings and the construction of lunar bases, are made possible by the mission. Furthermore, Chang'e 6's accomplishment establishes China as a pioneer in lunar exploration and science, paving the way for global partnerships and increased power to shape humanity's destiny on the moon and beyond. The Chang'e 6 findings have ramifications that go well beyond the moon. The genesis and development of other terrestrial entities in our solar system, including Mars, Mercury, and Earth, can be better understood by comprehending the moon's early molten condition. It makes sense that analogous processes would have taken place on larger planetary bodies if the moon, a relatively tiny entity, experienced global magmatic differentiation. As a result, the lunar magma ocean theory provides a crucial framework for understanding the evolution of planets. Scientists can gain a better understanding of the circumstances that led to planetary diversification, crust development, and volcanic activity throughout the solar system by contrasting the moon's geological history with that of other worlds. The hunt for habitable worlds outside of our solar system may benefit from these discoveries as well. Determining whether rocky planets can sustain life requires an understanding of their thermal and chemical evolution. Future expeditions like Chang'e 7 and Chang'e 8 are part of China's larger lunar exploration program, which already includes the Chang'e 6 mission. A crucial first step toward a long-term human presence on the moon, these missions seek to explore the polar areas of the moon, look into resources such as water ice, and test technology for in-situ resource usage. In these endeavors, international cooperation is probably going to become more and more crucial to celestial bodies, not just the most accessible ones. There is no question that fresh information will surface as Chang'e 6's samples are examined in labs all around the world. However, the mission continues to serve as a reminder of human ingenuity, curiosity, and the never-ending pursuit of knowledge about our place in the universe. The moon is today understood to be a dynamic globe with a complicated and fiery past, despite earlier being perceived as a static and lifeless orb. We are now closer than ever to learning the whole truth about our nearest cosmic neighbor because of Chang'e 6. If you love exploring the mysteries of space and want to stay updated on the latest discoveries, don't forget to like, subscribe, and hit the bell icon.